Hello everyone, myself Dr. Ashalata KS. In this session, we are going to discuss implicit and explicit functions, partial derivatives, implicit and explicit functions. Equations such as y equal to x square, y equal to 1 by x, y equal to sin x are said to define y explicitly as a function of x because the variable y appears alone in all these functions. The equation yx plus y plus 1 equal to x is not of the form y equal to f of x but can be put into this form by a simple algebra. We say that y is defined implicitly as a function of x by means of this equation. The actual function being given explicitly as, if you simplify this, y equal to x minus 1 divided by x plus 1. Now we shall know about partial differentiation. Let z equal to f of x comma y be a continuous function of two independent variables x and y. In this function, if y remains unchanged and x alone varies, then z becomes a continuous function of x alone. If this function possesses derivatives, then this derivative is called partial derivative of z with respect to x, or the partial differential coefficient of z equal to f of x comma y with respect to x is also defined as limit delta x tends to 0 f of x plus delta x comma y minus f of x comma y divided by delta x, provided the limit of this function exists, and symbolically the partial derivative of z with respect to x is given by dou z by dou x or dou f by dou x, or you can also represent it as fx. Similarly, the partial differential coefficient of z with respect to y is defined as limit delta y tends to 0 f of x comma y plus delta y minus f of x comma y divided by delta y, provided the limit of this function exists and is symbolically denoted as dou f by dou y or dou z by dou y or fy. Fx and fy are called the first order partial differential coefficients or partial derivatives. The second order partial differential coefficient is given by if you differentiate the first order partial derivative, that is dou z by dou x with respect to x, that gives dou square z by dou x square, and this is called the second order partial derivative of x. It is given by limit delta x tends to 0 fx of x plus delta x comma y minus fx of x comma y. Here fx refers to first order derivative, partial derivative, whole divided by delta x. So dou y by dou y of dou z by dou y, that means if you differentiate the first order partial derivative of z with respect to y, again with respect to y, you are going to get dou square z by dou y square. That is the second order partial derivative of z with respect to y. It is given by limit delta x tends to 0 fy of x comma y plus delta y minus fy of x comma y whole divided by delta y. Next, if you differentiate the first order partial derivative of z with respect to y with respect to x, that becomes dou square z by dou x into dou y, and it is called mixed partial derivative. It is given by limit delta x tends to 0 fy of x plus delta x comma y minus fy of x comma y divided by delta x. Similarly, if you differentiate z first order partial derivative of z with respect to x with respect to y, you will get dou square z by dou y into dou x equal to limit delta y tends to 0 fx of x comma y plus delta y minus fx of x comma y whole divided by delta y. So these two partial derivatives are called mixed partial derivatives. For almost all the function, these mixed partial derivatives are equal. We shall know this by an example. So again, this second order derivatives can also be represented by or can also be denoted as dou square z by dou x square as fxx, dou square z by dou y square as fyy, dou square z by dou x into dou y as fxy, dou square z by dou y into dou x as fyx. Rules of partial differentiation. The process of finding the derivatives with respect to a single independent variable and holding holding constant of all other independent variable is called partial differentiation. So remember, while applying the partial differentiation, while differentiating with respect to one variable, we have to keep all the other independent variable as constants. All the rules of differentiation applicable to a function of single independent variable are applicable for the partial differentiation of the function of several variables also. Okay, here is an example. Verify dou square z by dou x into dou y equal to dou square z by dou y into dou x for the function f equal to x to the power of y. Okay, so that means we have to show the mixed partial derivatives are equal. We shall consider the given function as equation 1. Now differentiate equation 1 partial with respect to x. So x to the power of y differentiation is y into x to the power of y minus 1. Call it as equation 2. Now again differentiate equation 2 partially with respect to y in order to get the mixed partial derivative, that is dou square f by dou y into dou x. Okay, so we have to differentiate this with respect to y. So this is one function, again this is also one function of y. So that means product of two function. So you have to apply product rule. After applying product rule and simplifying, you will get x to the power of y minus 1 into y into log x plus 1. Call it as equation 3. Now differentiate equation 1 partially with respect to y. Okay, so what is equation 1? It's x to the power of y. If you differentiate this partially with respect to y, we have to keep this x as constant. So then this function becomes constant to the power of variable. That means it is of the form a to the power of x. What is differentiation of a to the power of x? It's a to the power of x into log a. And the same manner here, the differentiation of this with respect to y gives x to the power of y into log x. Now again differentiate this equation 4 with respect to x. So this is one function of x. Again this is also function of x, product of two functions. Go for product rule and simplify. You will get x to the power of y minus 1 into y into log x plus 1. Call it as equation 5. Now carefully observe equation 3 and 5. What is equation 3? It's x to the power of y minus 1 into y into log x plus 1. Again, what is equation 5? It is the same. Therefore, dou square f by dou x into dou y is equal to dou square f by dou partial derivatives are equal. We shall go for one more problem. If u equal to e to the power of minus y into cos of x minus y, then prove that dou u by dou x plus dou u by dou y equal to minus u. Okay, now we'll consider the given function as equation 1. Now differentiate this equation 1 partially with respect to x first. You will get dou u by dou x. Since we are differentiating with respect to x, y is constant. Therefore, this function becomes constant. Keep it as it is. Now differentiate cos of x minus y. What is differentiation of cos? It's minus sign. Minus sign of x minus y into differentiation of this x minus y with respect to x. You will get differentiation of x is 1. Since y is a constant, what is differentiation of this? It will be 0. 1 minus 0. But what is 1 minus 0? It's 1. So you will have minus of e power minus y into sine of x minus y. Call it as equation 2. Now again differentiate equation 1 partially with respect to y. Okay, so this is one function of y. Again this is also function of y. Product of two functions. Go for product rule. Okay, keep the first function as it is. E power minus y as it is. Now differentiate this cos. So you will get minus sine of x minus y into differentiation of this x minus y with respect to y. So what is differentiation of x? It is 0. And what is differentiation of minus y? It's minus 1. So 0 minus 1 is minus 1. Plus, keep the second function as it is. Now differentiate the first function. It's e power minus y into minus. So simplify. E power minus into minus, that becomes plus. So therefore it is e power minus y sine of x minus y minus plus into minus minus cos of x minus y into e power minus y. Call this as equation 3. Now add equation 2 and 3 in order to get dou u by dou x plus dou u by dou y. Okay, if you add these two equations, what you are going to get? It's minus e power minus y into sine of x minus y plus e power minus y sine of x minus y minus cos of x minus y into e power minus y. Okay, so these two functions will get cancelled. You will just left with this term. It is minus e power minus y into cos of x minus y. But what is this? Look here. This is nothing but the function u. So here we are going to replace this function with u. And you are having minus here. Therefore it is minus u. Hence the result. This is one more problem. Go through this problem. If u equal to x over y plus z plus y over z plus x plus z over x plus y, then prove that x into dou u by dou x plus y into dou u by dou y plus z into dou u by dou z equal to 0. Differentiate the given function partially with respect to x, y as well as z. Then multiply those equation by x, y and z respectively. Then if you add those three equations, you are going to get the required result. Okay, so we'll go for the next problem. If u equal to sine inverse of x by y plus tan inverse of y by x, then show that x into dou u by dou x plus y into dou u by dou y equal to 0. Okay, so here one term is missing, that is y. So the problem must be x into dou u by dou x plus y into dou u by dou y. Okay, make a correction there. It must be y into dou u by dou y. Okay, so this is equal to 0. Now we'll consider the given function as equation 1. Given equation is equation 1. Now differentiate this equation 1 partially with respect to x. Remember, we are differentiating partially with respect to x means we have to keep y as constant. Okay. So dou u by dou x equal to, what is differentiation of sine inverse? It's nothing but 1 over square root of 1 minus x by y whole square into differentiation of this x by y with respect to x is 1 by y plus, what is tan inverse of y by x differentiation? 1 over 1 plus y by x whole square into differentiation of this y by x with respect to x is, y is constant, keep that as it is. What is 1 by x differentiation? It's minus 1 by x square. Now simplify this. Here take the LCM. What is the LCM? Y square. You will get y square minus x square divided by y square. So if that y square comes outside the square root, that becomes y. That y will goes to numerator. That y and this y will get cancelled. Okay. So again here, again take the LCM. X square plus y square. This x square goes to numerator. That x square and this x square will get cancelled. So you will left with 1 over root of y square minus x square minus y by x square plus y square. Now multiply both sides by x. So you will get x into dou u by dou x, and this is x by root of y square minus x square minus x into y divided by x square plus y square. Call it as equation 2. Next, differentiate u partially with respect to y. We are differentiating partially with respect to y means you have to keep x as constant. Okay. So dou u by dou y equal to, sine inverse differentiation is 1 over square root of 1 minus x by y whole square into differentiation of this x by y with respect to y means x is constant as it is. 1 by y differentiation is minus 1 by y square plus tan inverse of y by x differentiation 1 over 1 plus y by x whole square into differentiation of this y by x with respect to y, it is 1 by x. Again after simplification you will left with minus x divided by y into root of y square minus x square plus x by x square plus y square. Now multiply both sides by y. You are going to get y into dou u by dou y, which is equal to, so y in the numerator and in the denominator, that will get cancelled. You will left with minus x by root of y square minus x square plus x into y by x square plus y square. Call it as equation 3. Okay, now add equation 2 and 3. What is equation 2? Observe the LHS. X into dou u by dou x. In the equation 3, it is y into dou u by dou y. If you add those two, you will get this LHS. And now observe RHS. X by root of y square minus x square, and that will get cancelled with this minus x root of y square minus x square. Again minus x y by x square plus y square, that will get cancelled with this x y by x square plus y square. So you will left with 0. Here are some problems on partial differentiation. Try to work it out.